Okay, let's come back to the class. Okay, in the second hour, I'd like to show you some result of word embedding and review some classic papers. Okay, and as you can see that here is a word embedding um, link right here. Okay, so you can just simply just click it. Okay, and it goes to this page. Okay, that is the some introduction to word embedding. Okay, you can see simply just click this one, embedding projector, right here. Okay, so here's the result. Um, when we do language model, as we mentioned before, by using CBAL or using skip gram, okay, your sentence will eventually break down into words, and the words um, will be later represented as a vector. So you now you have vector to represent the word, and of course the vector is quite large. Usually we use 300 dimension or even more to represent a word in English, okay, or in another language. So here we have the result of that latent space, the word latent space. So you simply just project your 300 dimension words, okay, the original uh, word embedding vector to, for example, right here, here is an interactive user interface, so you can click different type of uh, analysis or projection tools to help you to uh, observe, okay, visually observe the word in the latent space. Of course, it is a 3D because we can only project 3D image 3D images. So for example, in this case, it has 10,000 word by using word2vec, which is skipgram or CBAL, which we introduced before. Okay, so after that, they project the word latent space by using PCA, which is principal component analysis. We have told it before, and using 3 dimension right here, component 1, 2, 3. Although the cumulative variance, which is stated right here, is 8.5%, which is far away from 100%. That means the images, the 3D projection you displayed right here may not correctly represent the original. For example, I think this right here, original 200 dimension, which represent the word itself. We use only three dimension by using PCA right here. But actually, you can still take a look at this, or you can simply just click random one of them. Okay, so you can just do anything. Okay, so we pick a word which is far away from the center. Okay, so you can see that okay, I click a data point in this 3D projector, right? And the word I select is creator. And at the right hand side, it shows there are several different near this point in the space. Okay, so I click creator. Another word near creator is founder, and then designer, character, author, inventor, blah 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 blah. So that means those words are embedded into the embedding space, right? And they are close with each other because they have similar meanings. We mentioned it before. Because those words, those vocabulary are interchangeable in the original corpus. For example, Wikipedia. Okay, that is 10,000, right? 10,000 maybe Wikipedia or some corpus. In that corpus, maybe the creator, founder, and designer, those words are interchangeable words. So they have this almost the same semantic meanings. Okay, so that is how did you explain this specific word latent space? For example, establish has a semantic meaning related words: maintain, established, create, build, impose, determine, something like that. OK，好，中文再讲一遍哦。这个我们上次有看过一次了哈，就是说你在 Word Embedding 里面，你可以你以这个例子来说啊，他找了10万对不起，1万个应该是文章吧，里面都是英文。然后呢，他把东西用 skipgram 或是用 C 报把它弄成200维的字啊，所以这就是200维。那他再用 PCA 去 project 到3维，那这是3维的资料。那因为 PCA 因为300维降成3维实在是太夸张了哈，所以这里面只有8.5% 的 variance。total variance 而已，所以这个图其实并没有很准确。好，你可以随便点一些字出来，好像我们刚刚随便点一些字，那这些字就会变成是说，在那300维里面，那个字会跟哪些其他字是相近的啊？那它就会列在右侧。那图就不是很准了哈，因为有些字其实你觉得很远嘛，对不对？实际上不是，在300维，在200维里面啊，这里有200维哈，左边这边有个200维，在200维的原空间里面可能很近。可是因为现在硬要 project 到3维上，形状会变嘛，所以就不是很比较不近的。但是你还是可以这样做的你还是可以这样把这些比较近的字找出来。那这样你的 你的 words 就可以非常有效的用 vectors 来表示，好吗？这是其中一种方法。Okay, that is one of the way to represent word into by using vector. Okay, so here is word to vector. You see, here's the word to vect, right? So of course that is okay. So of course, bird is another way to encode the entire sentence into vectors. Okay, I would like to show you some interesting things is that right here. When we have a language model like BERT, okay, as we mentioned before, I think it's right here, okay. As we mentioned before, we have two different way, like CBAR or skipgram, okay. Try to figure out the vectors, right? So basically, it looks like a close, right? Close test, right? For language model like what we do here is BERT, right? Actually, BERT can do closed test as well. So basically, take a look at this one, okay? We have a lot of sentence, okay? Right? And we have tokens right here. And again, if it is a BERT, it has multiple layers of the attention layer we introduced before, right? So the attention layer can input multiple input right here. So basically, how to BERT do such kind of closed task, okay? If this is, okay, I have to draw it more. For example, a book. Okay, maybe the sentence has the first 4 words of this sentence is like this, okay? And as we mentioned, we have several output, right? And still, we can do close task. For example, we simply just remove some of the word in the original token. For example, this word I replace it with a mask, which is a special token, right? Which is a special token right here. So how do we do close test? And then we can create another new neural network, append on the end of this bird, which is right here. We have an NN-based classifier. It can be a dense neural network, it can be a convolution, it can be a RNN, which is okay. Okay, as we mentioned before, O3 is the output of T3, right? But actually, the O3 still have the information because we know it is a bird, right? Still has the information of all the input because all the input will be considered jointly to output O3 because the bird right here is usually it is a neural network, a very complex neural network, and it consider all the inputs. So O3 will still consider all the position information, all the token information, but at this moment, O3 need to output something considering T3. That is why we use the word attention, because O3 pay more attention on T3 and of course the words around T3. So basically the O3 here is the vector right here, the output of O3, so that is a vector right here. So we can create another neural network classifier by feed O3 into the classifier. And what is the output of this blue classifier? Actually, it is another vector. And the index of the vector is exactly the dictionary you used at the first beginning when you encode this is a book, something like that. So basically, the classifier will output a softmax right here. Each one of the element corresponding to one vocabulary in the dictionary. So that may be this, the book, until it depends on how many vocabularies in your dictionary. Since it is a softmax, right? So it is a probability, it looks like a probability. So basically the O3 is pay more attention to T3. And T3 currently it is masked, right? But it will consider, okay, there are some other words around the mask token, which is this is and book. So the O3 knows, okay, I should output a probability, something like that. Because it is softmax, so it looks like a probability. So that means I should select one of the words in the dictionary and given it the word probability. So in this case, if the BERT is well trained, if the neural network based classifier is well trained, and then if you fit this is mask book into the BERT, and the BERT output TO3 according to currently the mask is at the third position. So you use the O3 to fit into the trend neural network based classifier. So it will select one of the word. It will give the probability which word should be output according to O3. And in this case, A should have a very high probability to do such kind of things. So basically, when you do such kind of things, and you feed tons of sentence. Maybe you can collect them from Wikipedia and feed them all in this kind of structure. And you can randomly put the mask, replace the mask token in any place, T1, T2, or TK, any place. And teach BERT to learn how to do close and use the neural network classifier. Cooperate with your dictionary. Okay? So that is how we teach BERT to do close task. 好，那这个是一个克漏字的，就是我们前面在 C 报或是 Skipgram 都有讲到克漏字这件事情嘛，对不对？那 BERT 要怎么做克漏字？因为它的结构就是黑色嘛，对不对？所以你就去 Wikipedia 上去捞几十万、几亿个英文的句子过来，然后把下面布置好，然后你呢用一个特别的 mask 的 token random 的取代掉里面的任何一个字。以这个例子来说，就取代掉 A 这个字，然后后面因为 A 这个字在3号的位置嘛，对不对？那我们说中间这个是 BERT 是用 attention 的 layer， 对 ，attention 这个 layer 就会特别在 O3的地方关注 F3，对不起 T3 的这个字。大家记得哦，这个 BERT 它里面用的还是有很大一部分还是 fully connected， 所以 O3 其实不是只是真的看 T3 是什么 ，O3 还是会去看一下 T1、T2、T3、T4到 TT 里面的一些 information， 然后配合 T3 还有 T3 的位置去 output O3。好，这件事情是 BERT 会做的哈。那 O3 输出是一个 vector 嘛，那个 vector 会进 NNBase 的 classifier。那这 classifier 要做什么呢？它很简单，它就是搭配你的 dictionary。所以你 dictionary 如果现在里面有10万个字，那这个 classifier 就是10万个字的 softmax。所以在 training 的时候啊，你当然是丢 this is mask book 进去，这是 x 嘛。那个 A 啊那边就要填1，因为这是 y 嘛，因为这个会被视作为 x， 这个会被视作为 y 嘛。它是一个整体的 training， 所以你输入你从 corpus 里面拿到是 this is a book 没有错，可是你在 training 的时候是 train this is mask book， 然后那个 y 呢就会是右上角就是右上角那个 dictionary 是1000000，就表示说如果你看到 this is book 的时候，这个 classifier 应该要输出 a 那个字，那你这个 mask 可以随便乱动。因为它是 random 去取代，所以你可以输出，你可以在同一句话里面再 train 一次。我换一个颜色哈，你可以再输入 this mask a book。那紫色这一组 training data， 它的 y 应该是就会是0100000，在 training 的时候。所以这样子，你就是用 corpus 去说，哦，我有一堆的英文字，然后我就随便遮掉一个字，那个字呢，最后在 dictionary 里面我就把它设成1。那你在 training 的过程中，这里有一堆 weight 嘛，对不对？那这里有一堆 weight 嘛，这2个 weight 就会被适当的 train 好。那么那我们就 weight 1跟2好了。那 weight 2当然是做这个那个字的猜测嘛，对不对？根据 O 是什么来做字的猜测嘛。可是 weight 1这个时候 BERT 就会很厉害，因为它很会做克漏字。它的 O3 呢，几乎就要是能够代表 A 这个字了，因为它瞻前顾后的看了一下 this is 跟 book 这3个字，所以 O3 几乎就要能够输出一个向量，能够非常的代表 A。而这个向量等下进到 W2 的那个上面那个紫色的 W2 去做 NN classifier 的时候，它就会输出 softmax， 就是 O3 经过处理之后，然后再过的 softmax。那它应该要在 A 那个地方，那个几率要很高。那如果是紫色的话，就是在 is 的那一格几率要 softmax 的几率要很高。所以我们这样就教会了 BERT。克漏字，因为东西都会存在那个 W1 里面，可以吗 ？So here's another example that, for example, we can randomly use mask on the training sentence. So we can mask is. So for example, we can input this mask a book. So at the end, after the classifier, after the softmax, the output should be 0100, because that represent sorry, hmm? Sorry, that should be is, okay. So that means the probability of is the highest one. So we teach BERT and the upper classifier to know how to do closed task. So we have weight 1 for the BERT, weight 2 for the neural net classifier. So at the end, weight 1 and weight 2 will be trained. If you fit tons of sentence into this kind of closed task training, and you can randomly put your mask in any place of the sentence and try to teach BERT and the classifier how to do closed task. Okay, so that is it. Of course, there are a lot of different structure can teach BERT to do different kind of language test, but I think close is one of the most important and most useful one. Okay. Okay, let's go back to go back to here. Okay, I would like to share some of the we would like to go over some basic papers right here. Okay, I provide two basic papers, so you have to read those papers on your own. But I will go over some important concept in this hour. Okay, we have two papers right here. You can simply just click it to download the PDF files. Those PDF files are highlighted. Okay, so let's take a look. Right here. Okay, so that is the first paper I like to discuss. Okay, that is the brief history and the overview of intrusion detection. So basically, you have to learn some basic definition or some concept of intrusion detection so that you can write the correct analysis program. Okay, so that is this paper is published quite early, okay, and 2002, because that is a basic concept. Okay, it did not change quite often, right? R.A. Krumer and G. Right, Giovanni Vina. It is they are professors in UC Santa Barbara. Okay, let's take a look at this paper. Okay, we can do that. Okay, as we mentioned in the very first class, okay, the reason why we need such kind of detection system is that security is very important, because if there are some security incident occurs in your organization, you may suffer from a tangible or intangible loss. 中文说就是我们为什么要做这些系统啊？为什么要提前得到预警？就是因为一旦发生资讯安全的事件的时候，你的公司会得到会遭受到这些所谓有形跟无形的损失啦。那这些损失都是不是我们想要的。The reason why we do such kind of a system is because we don't want such kind of tangible or intangible loss. Okay, that may destroy our business, right? So that's the reason why we would like to install a lot of firewalls, intrusion detection systems, antivirus engine in your company. Okay, so let's take it. So I think it is necessary to install such kind of monitoring system. Okay, as we mentioned, security has three different concepts. I'm not sure if you remember them. Confidentiality, integrity, accountability. Uh, CIA, confidentiality, integrity. Yes, accountability. Accountability. CIA. Okay. For for the assurance purpose. Okay. We have monitoring job need to do. We have testing job need to do, and we have auditing job need to do. Right? Monitoring, assurance, monitoring, auditing, and testing. So in that case, we need to set up a lot of monitor in our company so that we can gather such kind of information. Otherwise, if you just simply buy a firewall or buy a antivirus system and just install it in your company, you do not know if they have logs, right? But you need to analyze those logs, those monitoring logs, right? Otherwise, you don't know what exactly happens in your company or your organization. Okay, so the important things is that the next step in intrusion detection involves audit logs. So next hour, okay, we will show you how to analyze tons of logs by using language model or some other interesting mechanism in the real world. Okay, so those logs are the evidence. It's right here. Are the evidence. I think you can. At the left-hand side, the red lines, okay, is the evidence of unusual or malicious behavior. So we will show you some malicious logs next hour, okay? However, we cannot, okay, next red line, we cannot manually analyze it because it has tons of text, words, sentence need to be verified by a security expert. And security expert has no time to review all those logs. So we need a very nice forensic tools, which is of course AI in our class. So programs to analyze data is much more convenient and efficient. But human beings, I mean security expert, they are expert because they know what kind of logs, what kind of content in the logs are considered as malicious. But AI does not know. So we need security expert to teach AI or deep learning or a language model to know, to realize, okay, if I read a sentence, which is a log, and how logs looks like under different situation. For example, under being attacked, or just is a normal execution of the system. So the log does not show any malicious sentence or malicious event in your log files. OK， 好，那我们是这样说的，就是说，就红色那些字哈，我们没有办法靠人去做这个判断的，我们需要一个很好的 forensic tool。那 program 是最好的。那以现今的标准来说，就是 AI 嘛，deep learning 嘛，好 language model 嘛，它帮你去看那些 log。可是你要知道，人之所以成为 expert， 是因为他们很有经验，他们知道什么样的 log 对应什么样的攻击，然后那些攻击要怎么样被辨识出来在 log 里面。可是 AI 不知道。尤其是 language model， 他们只知道英文，所以 language 你要想那些 language model 当初在学的时候，他们是只看英文 Wikipedia 上的字，所以他们很会英文的克漏字，但是 Wikipedia 上的各种克漏字，所以他很会 Wikipedia 上的东西英文。可是他对资讯安全有了解吗？没有，他们对资讯安全实际上没有了解的。所以我们通常会在 language model 里面会让他多学一些资讯安全的事情。那资讯安全的事情就必须要靠 expert 去 label， 比如说。给 given 一个 log， 那 log 里面它是写英文嘛，还有一些数字嘛，还有一些参数嘛，对不对？可是 expert 会很知道说，哦，你的参数是这样的时候，或者那些 log 是怎么样排列的时候，有哪些 pattern 的时候，或是哪些 log 的 event 出现的时候，就可能是某一些攻击。expert 因为他很有经验，所以他知道。可是你叫 BERT 或是 language model 这种很会做英文克漏字的东西去 看一个 security 的 log， 他应该是看不懂的，大部分都是看不懂的，所以我们必须要教他，好吗 ？OK， so at the right hand side, okay, at the right hand side, okay, doing such kind of things is not an easy attack, right? So at the right hand side, increasing security concerns count these new attack techniques and continuous changing in the surrounding computing environment, because there's always new attack. There's always new things need to be learned by the security expert. So we would like to create a more intelligent system, okay, based on neural network or language model, so they can quickly learn different new security techniques, new attack techniques, or new attack event. Of course, as we understand, the language model or the AI, the deep learning algorithm that we told you, they are basically supervised learning. So they need labels. So human beings currently, human beings are no need to analyze the larger amount of text-based data. They only need to label what exactly they would like to label on some logs or some data. Okay, so AI can learn the label, the relationship between the label, the target, the Y, and the input, which is a log or some packet, some data. Okay, so basically, security expert can firstly label a data set. The input can be logs, can be P files, can be log files, can be text, can be sentence, whatever, and create the corresponding target labels, which is Y, right? And help that AI to learn such kind of a relationship. And then if we have a new data set, new logs, new packet, new P files, and we use the AI system to analyze the new data set, okay? Maybe part of the data can be analyzed because based on the old knowledge learned by the AI, they can still apply on the new data set. But we believe most of the attacks will be detected using old knowledge. Okay, and then there's some rest of the data. Okay, the AI may output. Okay, I don't know what exactly the logs says. I don't know whether there is an attack in the P file or in the packet, but the amount of those packet logs and files will be less than the input, right? Because most of maybe most of the data in the new data set will be detected by the old knowledge. So AI can pick some new data point, says, okay, to the experts, and expert, okay, I don't know how to analyze those new data set because I have never seen them before. So can you help me to label them again? So the expert will need to label the new data set which has not been cannot be analyzed by the AI because AI does not have enough knowledge to do such kind of prediction. So it is a kind of iteration. Okay, every time the expert provide new labels and on the data, and AI can learn new knowledges, and so on and so forth, so on and so forth. And at the end, the AI will be strong enough to have most of the knowledge in experts' mind, and only very, very few data, okay, which AI are not be able to analyze because they cannot output high enough probability to say, okay, that is attack or it is not. And of course, expert can involve the detection mechanism to help the AI to do such kind of prediction by providing new labels. OK， 好，中文是说，实际上这种 AI 跟人跟 expert 是互动型的啦哈。你可以先拿一批旧资料叫 expert 去 label， 对吧？然后 expert label 完之后呢，叫 AI 去学。那 AI 学完之后呢，你为的就学好了嘛，对不对？你可以再拿一堆新资料进来。那新资料进来的时候，因为攻击资料有时候蛮重复的、不是每天都有新攻击了哈。 那 AI 就可以说啊，那我把某些我已经知道，而且信心水准很高的，都跳出来了。剩下有些东西，可能我最后的 softmax 或者什么东西就很低，就是不够高嘛。那我请人类再去帮我标一下。所以它就这样一直循环，AI 就会越来越健全，它就会学到越多跟 expert 有关的东西，expert labeling 有关系的东西。Okay, that is the overview of the things. Okay, so but the most important thing is that you have to collect enough data so that expert can label enough label data so that the AI can do the AI can do supervised learning. So there is a problem called data collection issue, and the quality should be concerned because the labeling result should be very accurate so that AI can learn the label. Okay, and as we mentioned before, there are two types of detection techniques: the red words, which is anomaly detection, and the misuse detection. We have talked about before, so just take some time to look at this paragraph. Okay, we have talked about before. Okay, so I think that is the things I would like to share with you. So please read those paper, okay, on your own. I would like to show you another paper, which is right. Sorry, which is right here. The second one, which is the first one, which is an introduction to intrusion detection. Okay. So let me see where it is. Okay. So here is. Okay. It is a relative longer paper. Okay, but I think there are some important things. So I already highlight some important sentence. So when you read the paper, okay, you have to read the paper on your own. I will just go over some basic ideas right here. So when you go over this paper, make sure you read all the things. Okay, so again right here. Again right here. Every time when we talk about security or a security system or security management, you have to think about confidentiality, integrity, and assurance, which is CIA, right? Okay. So here there are some we say not really feasible approach to do such kind of things. For example, in practice, usually you cannot write a bug-free right here. You cannot find a bug-free software. It is inevitable that when programmers write their program, and there's always a bug. So system has flaws. 就是说系统总是会有缺陷的啦，所以你不可能说你做一个完美的系统或者程式，然后你就不做资讯安全的事情，这通常是不可能的。所以资讯安全有其必要的存在，是很多事情是不完美的。像 A 这边就写是不可能的。然后像下面第三行写的是还有一些加解密的问题，加解密时间久了总是还是会破防的啦。So there's always some reasons that you indeed need a security system. So to detect them, we usually use the word, okay, intrusion detection systems. Okay. So and again, okay, it's the same. You need the audit data, the record of activities of a system, which log a file to a file. So the audit data could be system log file, could be the dynamic analysis result of a PE of a executable file. It's a sequence call like we have done in our homework. It can be a PE file, okay? The malicious file you left, you preserve when you have been attacked by the malware, and you keep the files for the further analysis. Or you can be the packet. When you are under attack, you collect the packet from your firewall or your gateway. Okay, so but however, there are two different intrusion data systems, which is the real time and the postmortem analysis. Real time means when the you have to set a monitor and continuously monitor the for example incoming packet. You have to analyze the incoming packet at real time, so that if there's any malicious things been detected, you can directly, for example, block the packet so that no further packet will come into your system. Or you can do it as a postmortem analysis, which means you collect all the information and you analyze those information afterward. 就是你在做这个资讯系统的时候，通常就是这样子，你要不是及时做嘛，要不就是事后做嘛。那及时做的问题在于运算的困难度，因为你不太可能一边 train 一边测试吧，所以你一定是先 train 完之后测试。可是测试之后有新东西，你就只能用旧知识测了。那 postmortem 的话，它的好处是你比如说你每天收集封包，你不太可能马上测嘛，所以比较好的状况有可能是你测完之后，你隔天晚上半夜的时候跑一个 AI 的模型，然后明天早上起来看报告，比较有可能是这个样子的了。Okay, we have talked about this sentence at the very first class in our course. What is risk? What is attack? Okay, penetration means attack. Okay, so there are several different roles of intruders, external and internal, and most of the time, some serious, severe attack are made by internal intruders. So you have to make sure you understand this thing. 有很多时候攻击比较重大的攻击都是内部员工在捣乱的，所以 internal 的 intruder 也是很重要的。Okay, again, all the paper about detection, they will talk about what is anomaly detection. We'll talk about it next week, and the other is misuse detection. And we mentioned it before. For anomaly detection, what you learned. So the highlights right here. For anomaly detection, you detect anomaly. And what is anomaly? Anomaly is the deviation from normal means anomaly. 中文异常侦测的异常叫异于正常嘛，所以你要先知道什么叫正常，才是异于正常。Anomaly detection, you have to know what exactly is normal. Then you try to do some kind of detection to detect if there's a deviation from the norm, and we say it is anomalous. So from this, for this concept, when you do data analysis, if you apply anomaly detection, that means you have only normal data. And when you do anomaly detection, you create a model for normal data. So you have a model, right? You don't have Y because you don't have label. You only have normal data. You don't have abnormal data. You don't have attack data. Okay? So under that constraint, under that definition, you have to describe your normal data by using AI or your model. And then if there's a new data comes in, you have to compare the new data with the model you have, which is a normal model. If the new data is deviated from the normal model, then that is a anomaly. So let's draw a picture. Okay, see if you can catch what I'm talking about right here. Okay, so that would be this one. I think that is a very important concept, but most people will neglect neglect such thing. So for anomaly detection, okay, you have to build a normal model first. So for the data you have, they are all normal. So you have 1, 2, 3, x, and then usually you don't have y because all of them are normal. Now you cannot label 0 as normal and 1 as attack. You don't do so because in the definition, right? In the definition right here, it says you establish a normal activity profile. That means you have only normal data to create normal profile and use a normal profile, which is right here, and you create a model to represent the entire M. So it should be, you create a normal model to represent this data. There has no labels. So most of the time, it should belongs to unsupervised learning. So most of the time, maybe we can use an autoencoder, right? We have an autoencoder such like this, right? That's X. That's an autoencoder. That is X prime. So we can represent the data in a new latent space by right here to represent the original N data using the Z dimension, not the original X dimension. So in that Z dimension, those normal data will be represented somewhere in the Z dimension. And most of the time, normal data also has some patterns. So maybe you can do clustering algorithm in the latent space, the autoencoder latent space, right? Okay, so what if there is a attack data, which is n+1 right here, and you collect all the information of its X, then you transfer into Z. And most of the time, because the attack, again, take a look at this definition. We would like to identify a abnormal activity or intrusive activities, right? There should be a threshold level, right? What is threshold level means? That means when the new attack data comes into the system, because the attack data is deviated from the normal data, which is the N data. So it should not be close to any of the cluster of the normal cluster in the latent space. It should be a little bit far away from the clusters, the normal clusters. That is what we call, there should be a distance or the threshold between the normal clusters, the central E of the normal clusters. If this distance is high enough, that means the attack data is quite deviated from the central E of the clusters, of those normal clusters. Then we can make a judgment. Okay, this red one is a abnormal, or we'll say whether it is an anomaly. Right? That is the definition of anomaly detection. 好，中文再讲一遍哦。黑色的东西是我们收集到的 normal 的东西嘛，所以你就要按照 normal 的方式去表示它。但是因为它们全部是 normal，所以基本上不太会有 y。那没有 y 的情况下，你只能做什么？做一些 unsupervised learning 嘛。那 autoencoder 算是一种还不错的，所以我们就可以做 autoencoder。所以可以把那些 normal data 画在 autoencoder 的空间里面，像右边那个样子。那因为 normal 的事情应该还是会有 pattern， 因为大部分的事情都是有 pattern 的，所以你就可以在 Z 空间里面去把那些 normal 的东西把它 cluster 在一起，那它们就是不同模式的正常的动作。当有一天红色的这个 attack 的 data 进来之后，因为 attack 是 deviated from norm 的，它跟 normal 是有差距的，所以它在过了这个 auto encoder 之后啊，这 auto encoder 会觉得说，哎，奇怪，这种资料我过去没有看过，没有转过，所以这个转换的效果会不好。它转换的效果不好的话，这个红色点很有可能就会离开那些原本那些黑色的点。那离开了之后呢，我们就可以设一个 threshold 去测，比如说一些 deviation 相关的东西，还有距离的 threshold。如果它离那些已知的黑点的中心就 central E 嘛够远，那我们就说，那它是一个 anomaly 了。所以基本上 anomaly detection 大概是这样子做的，没有 anomaly detection 在做2选1这件事情的，好吗？And we'll take some time to finish this view graph. Okay, so if you want to do misuse detection means we already know what exactly attack is, or attack is or normal is, right? So misuse means we know what exactly attack looks like. So basically, you can have again it's the same. So we know what exactly attack is. And usually in your system, you can find some time period and say, okay, in this time period, I would like to collect some data. And those data belongs to normal. So you can have a normal data set and a attack data set. Attack data set. You can, because normal is relatively easier for the system administrator or for an analyzer to collect when there's no attack happens, right? So basically you can have such kind of thing. So that belongs to supervised learning. So every different kind of algorithm which supports supervised learning, like SVM, like regression, like neural network, whatever, then you can use them in such kind of detection. So the basic, because in the papers, that is how anomaly detection is defined. You can only have normal activity profile. So based on that definition, you can only design some neural network or detection method based on this field graph. But in the paper, for misuse detection, the definition is you can collect attack data. You know what exactly data is, so you can recognize them. And if you can recognize them, you can you have the capability to collect normal data set and attack data set, and then it's quite clear you can apply any supervised learning on this such kind of data set. Okay, that is what we design based on the paper's definition. Okay. However, there's another. You can imagine that there's another things which we do not mention right here. Is what if I only have attack data, and I don't want to collect normal data. So that would be like this. That would be directly detect if certain new sample right here. I don't want to do supervised learning. I don't want to do a classifier which can classify attack or normal. Okay, what if I only want to collect attack samples right here, attack right here? And if there's a new sample, can I just simply match the new sample to the old attacks, to the known attacks? That is still okay, but the design of such kind of system would be a little bit strange. Like, for example, here is the X. x1 to like that. And you have a lot of attack data here. As I mentioned, usually normal behavior has patterns, but it is quite strange that sometimes attack, it depends on what kind of attack you collect. Some attack does not have pattern. They are individual attack. They are not related. So the random space or the X space, the original space of the attack would not have cluster. So we will be separate in the space. Okay. So if there's a new purple sample and you map it into the random space, it could be somewhere right here. So it is a little bit difficult for such kind of detection because it is far away from any other attacks. So it is a more difficult for you, for the analyzer to decide, okay, that is a attack or it is not. If this attack is quite close to a previous known attack, that is okay. But most of the time, if some new data sample is far away from every attack, every other attack, it is very difficult for you to know if it is an attack or it is not. So that kind of system is a little bit different because for normal data, it usually has patterns, routine patterns. Okay, so it looks like a cluster. But for individual attacks you collect, it may not have clusters. So the difference is like that. Okay, so that is the difference between anomaly detection. We will show you how to implement anomaly detection next week. Okay, so this week we will show how to do supervised learning. Okay, so there are some definition of misuse detection and misuse detection. So basically, here we have a word called model based. That means you model whatever you have learned from normal and abnormal. So that is right here. You need a model, and the model we use this in our class is basically a neural network model. But in the previous, maybe 10 decades ago, they used statistic models to describe x1 to xm. Okay, or they use certain rule-based model to present normal behavior and attack behavior. But currently, we simply just use neural network to do so. Okay, so there's some old state transition analysis is trying to use Markov model to describe normal behavior, but we don't use these things right now. We simply just use neural network. Okay. So okay, so I think we can stop right here. So next hour we will show you some code. Okay, so it is 11:15, right? So please come back at 11:25. Okay, 11:25. Thank you.